I'm going to be talking about the TIM model, and James was one of the team who helped build this wonderful model, which enables me to do my job and enables me to give this presentation today. And I'm going to be talking about changing the tyre while we're driving, and probably your first thoughts are, one, that's quite a foolish thing to do, and two, that's quite a risky thing to do, and probably unnecessary as well. And I will accept that it's risky, and I might accept that it's foolish, but unfortunately in this case it has been necessary. So I'll be talking about how we've been evolving our energy systems model as the same time as results are being fed into live policy making. And first of all, I'll talk about the scope of what we're doing. So we've got an energy systems model for the Republic of Ireland here in the Eastern Atlantic archipelago. And the why is that Ireland is passing climate legislation right now, and it's setting very ambitious targets for 51% cuts by 2030 from 2018 levels, which is an extremely rapid reduction in carbon emissions. And the legislation, in its current form, it's being debated by the lawmakers right now, requires carbon budgets to be set for cumulative emissions between 2021 to 2025 and 2026 to 2030, in each 5-year period thereafter. And our energy systems model tells us how rapidly each sector can be decarbonised and gives an idea of the sort of policies and behaviour change and infrastructure and investment that will be needed to meet that target. So that's why we're doing what we're doing. I'll talk about how we're doing what we're doing. Some of my colleagues have already presented on the Times Ireland model, and following this presentation, Alex will be talking more about the detail of that as well. So this is just a quick overview of the energy systems model. It's built on the Times family. It has a set of given inputs which are exogenous to the model, and then it finds a least cost pathway. Now, as you'll know, the challenge with a least cost pathway model is that it tends to flip between one technology and another. It either goes all into one or all into another as soon as the cost curves cross over. And then that's always a challenge, because you end up with two very similar scenarios and the technologies just flip. And the slightest change in one constraint or another. Now, we do have deployment rate constraints in there that help reduce this flipping between one technology and another, but it still can be very sensitive when you've got two or more closely competing technologies. And there are some sectors where we do have those closely competing technologies. For example, in domestic heating, Ireland has quite a lot of domestic heating. It's not a warm climate for a lot of the year. And at the moment, it's almost all fossil fuel powered. Very little of it is electrified, and the clean alternatives for domestic heating are all more expensive than the current option, and there's often not a lot to choose from between their costs, and that can give us this danger of the flipping between technologies. And that's something that is vulnerability for optimization models, but by running a panoply of models, a portfolio of different models with different constraints, we can start to unpick some of these sensitivities and understand why they're happening, and then communicate to the policymakers what the real story is behind it. So it's not about running one scenario, it's about running a set of scenarios and then building a narrative around the set of scenarios. Now, I'll talk about what we're doing. So we're talking about what energy system changes would be needed to meet these targets. As I said, these are very ambitious targets. So what we're talking about is absolutely huge changes to many parts of society within the next 8 years, between 2022 and 2030. The sort of cars people own, it will require them to get used to a new technology, electric vehicles, very quickly, in a very fast rollout of those, how they heat their homes, how new homes are built, how offices are heated, how industry works. We have a large cement factory here. We've got lots of industrial emissions, and all of those will need to change radically in the next 8 years. And our model helps unpick the efforts required for each of those sectors. And it tells us what the impact is if technology options become available or not. And that's something that changes live over time anyway. Year by year, we see big reductions in the cost of lithium-ion batteries and PV panels, in heat pumps, fast-growing supply chains for things like offshore wind, other technologies such as carbon capture and sequestration, and maybe moving a little more slowly, but there's still a changing landscape. But 3 years ago, we wouldn't have had much electric aviation in the model for 2030. Now, it looks like for short and medium distance that there's a fair chance that that'll be a viable option. So the technologies available are changing all the time. Month by month, the outlook is changing. So perhaps it's not that foolish to have a constantly updated model informing policy, because that's reflecting a reality. If we had a static fixed model and a fixed version of the inputs, then we wouldn't be able to reflect the changes that are happening right now in reality. There are a bunch of things that the model can't do, of course. The only perfect model of the system is the system, as you know. So there are always things outside the scope. And we try to be very clear with our policy-making clients about the things that are outside our boundaries, and that they all need other tools, expert groups, to help them understand. And as part of this, the recipe, the scenario, the constraints and assumptions, that's something we do in partnership with the client, and we have a very rapid iteration process between the models and the client to talk about what constraints and what assumptions they consider feasible. And again, that changes the inputs to the models, and that changes the outcomes of a given scenario. So who's doing this? Here I am in the top left corner with the TIM team, and you've met several members of the team already, and Alex will be speaking again shortly. I'm one of two fellows from the Ireland's Environmental Protection Agency, and there's a group of other experts as well. We feed our expert submissions into the Carbon Budget Committee, which is a subcommittee of the Climate Change Advisory Council, and they provide recommendations to government on what mitigation measures will be required and what suitable carbon budgets will be. As it happens, we're very fortunate that two members of the TIM team are also members of the Carbon Budget Committee. So we have a close linkage between what's going on in the modelling and the deliberations of the committee itself. And then all the risks and all of the pressures are about the timescale involved. And the Times Ireland model has been evolving for quite a few months now. And by March this year, we were able to put out a set of scenarios to external expert review. And that's resulted in another series of model revisions, provisions of early scenario results to the Carbon Budget Committee, and we're looking for model stabilisation around about summer. At the same time, all of the legislation that this model informs is being passed through by the legislators at the moment and being amended by the legislators. So we have the model development and the policy making going on in parallel. We can't finalise the budgets until the bill is passed, and that should happen maybe this month, maybe next. And our instructions from government is that our budgets should be ready to be recommended to government pretty much as soon as the bill is passed. And that's put a lot of pressure on the modelling team to get usable inputs into the process of the deliberations. I'm going to talk about how we're doing it, and in particular the aspects of what we've done that have enabled this close linkage between evolving model and evolving policy. And I may have stolen one of Alex's slides here, so you may be seeing this again with more detail on the technical stuff shortly. So it's all open source. We've got the Times framework, which is well established. So the foundation we're built on is very solid. It's not that we've got a brand new modelling framework developed from nothing. It's got a very solid framework, and that enables us to rapidly iterate on what we've got. And Alex has done fantastic work on very tight integration between our version control, our live model running, and websites which give charting of all of the key outputs, which means that a small number of button presses can take us from an updated model to published results on a website, which I can then take to the policymakers. And Alex will talk more about the technical tools that make all that happen. Sure, that's fantastic. And the other thing that's made it happen is endless meetings, which, as we're living in a time when everyone expects these to be online rather than in person, it's been much easier to have a very fast iteration of have a meeting, make some changes, come back to the next meeting a week later with a new set of scenarios or a new set of constraints, and show the outputs of those from the model to the next meeting. So this new environment has enabled us to do this very rapid iteration between modeler and client. And part of making this work at all has been about setting the client's expectations early on, that we're working with a live updating model. We will respond to their request for changes. And that means that the output of a given scenario last week is likely to look somewhat different to the output this week. And I'm sure many of you are used to using the George box observation that all models are wrong and some models are useful. And when we lay that on thick with our clients, that yes, we know our model is wrong and it was wrong last week and it's wrong this week, and we're constantly making it more useful. And that's why this week's results are better than last week's results. We've made them more useful. And that the use is in the differences between the scenarios, not in the individual results of a single scenario. We've got this rapid iteration between the modelers and the client. A couple of the really key things that have made a really big difference to this tight cooperation is that there is a policy-making client embedded in the modeling team. As it happens, we've turned out with three attendees of the committee in the team leader, Hannah Daly, the department leader, Brian O'Gallagher, and me as the EPA fellow, all work on the modelling and the infrastructure behind it, and go to the climate budget committee meetings. But my role is really there as, and it was designed in the fellowship, that my role is to be both the modeler and a policy-making client, that I have feet in both camps at the same time. So I'm a modeler in the client team, and I'm a client in the modeling team. And by trying to do it, by trying to change the tyre while we're driving, we've proved that you can actually do that. It is actually feasible to change the tyre while you're driving. And as I'm sure you understand, the biggest challenge here has been getting the policymakers comfortable with the week-on-week inconsistencies between the models. And for a modeler and a programmer, there's a lot to be said for consistency. It's a really valuable thing that we can run the same model with the same inputs and be sure we will get the same outcomes. And that's a test of a working model, right? We use the same random seed if necessary, but we can reproduce our results when needed. And our version control software and our archives of scenarios means we can do that. We can reproduce past results. But we've really worked with the client to make sure they're comfortable with the idea that consistency is also a constraint that would be an enemy of their policy making. And so we've got them on board from the beginning with the idea that they will see changes in scenario results week on week. And that's a direct result of us listening to them and improving the model as we go along. And that's put a huge amount of challenges on the team, and Alex and the team have been absolutely fantastic in turning around a bunch of scenarios with a slightly tweaked set of constraints, or running annually instead of 5 yearly, and producing these results and getting the website up and running with the new charts immediately. So it can be done. It takes a willing client, and you have to do a lot of stroking and comforting that you're not throwing them out there with imaginary numbers. But by very, very tight cooperation, very frequent iteration of communications back and forth, this is possible. It's been terrifying, and I heartily recommend it to you. Thank you very much.
Thanks very much, Andrew. Don't be scaring off any policymakers talking about it being terrifying. We're a little bit short on time, but I don't want to rush. Just to get a few questions and a bit of discussion. And so I see, Andrew, I know Zoom is terrible for finding questions when you're a speaker, so I'll read it out for you. Question from Stephen McGonigal in the north of Ireland. Are there examples using times across country borders? I'm not sure, is it country or country boundaries? Given single electricity model covering the north and south of Ireland, do you think there is scope or value in developing the TIM to include Northern Ireland data to produce additional outputs covering Northern Ireland? I guess that's going to bridge you, Andrew, and possibly Olex next as well.
Yeah. So yes, that there are certainly international and continental scale times. I think there's a times global as well. James, you probably know better than I do, but I think there are certainly times across country boundaries. Its geographical scope is very flexible, and yeah, it's we have a very complex situation where we have, but not a unique one. Much of continental Western Europe has grid. Denmark almost uniquely has this weird case where the western half of the country is attached to one synchronous grid and the eastern half is attached to a different synchronous grid. And that means that where we have a suite of models behind time, so we've got Plexos grid models, which help us cover the issues of frequency response and reactive power and so on. All of those have to happen at the single Irish grid level. So those models cover the whole island of Ireland and cover different legislations, just as if you're doing modeling for the what used to be the Nordel grid, the Nordics and Eastern Denmark, or the UCTA grid, Western Continental Europe and Western Denmark. You have to have a model that covers the entire synchronous area. So some of the models behind times do indeed cover the 6 counties of Northern Ireland and the 26 counties of the Republic of Ireland. There is scope to develop a times for the whole island of Ireland, and it may well be that in the next 5 to 10 years that becomes a core part of what we're doing. Right now, it's not something we do in times itself, but it is something that happens in the other models behind times, the things that are specifically concerned with the synchronous grid itself.
Great, thanks, Andrew. It's a good succinct answer. We better move on. I'm doing a very poor job in sharing this session.